Hey guys, today we're going to learn about Lewis diagrams for single atoms. So let's look at boron to begin with, the element boron, which has the symbol B. Now on the periodic table, boron is right near the middle. It's got atomic number 5, symbol B as I said, and the mass is 10.81. Now for a Lewis diagram, all you actually need is the atomic number. We're not going to care about the atomic mass so much, because in a Lewis diagram, you're not going to include the number of protons or neutrons. And remember, that's where your atomic mass comes from. All you need is your atomic number to get your number of electrons. Now, in a Lewis diagram, you're going to start with the symbol, which is just the letters that you see in the periodic table. In boron's case, it's a B, so I'm going to put a big capital B in the center. That's going to be the centerpiece of my Lewis diagram. Now, around this B, I have to put the valence electrons. The valence electrons, remember, are the electrons that go in the outer shell of an atom. In boron's case, we're going to have 3 valence electrons. And there's actually a few ways to find that out. The first way is to just think about it logically. The first shell of electrons always holds 2. Everything after that holds 8. So if we have 5 as the atomic number, we'll have 5 electrons total. The first 2 will be spent on the first shell. That leaves 3 for the outer shell. Hence, 3 valence electrons. That can get complicated when we move into heavier elements, though, with higher atomic numbers. The other way is to draw out a full Bohr diagram for boron and check what that outer ring says for the electrons. That's going to take even longer, though. Now, the method that I prefer is to just take a look at the periodic table. Now, on the periodic table, boron is in column 13. Column 13, all of those elements have a valence electron number of 3. All of those elements have 3 valence electrons total. That applies to boron, aluminum, gallium, and so on. That means that we know right off the bat, just by looking at the periodic table, that we have 3 valence electrons. Now, regardless of how you find that you have 3, around boron, I'm going to put 3 dots. And some teachers prefer you to pair these dots up as well. And in that case, I would just write it like that, with a pair and then a lone electron like that. Let's take a look at another example. So the element sulfur has the symbol S. If we look on the periodic table, sulfur has atomic number 16. Its mass is 32.07, but we don't care about that for Lewis diagrams. And it's in column 16. So number 16 and column 16. The column's going to come back in a second. To start off this Lewis diagram, we're just going to put down the letters, or the symbol. In sulfur's case, it's just a big capital S. S. And then around this S, we're going to put dots representing valence electrons, which is electrons in the outer shell. In the case of sulfur, we're in column 16. Column 16, all will have 6 valence electrons, because when you're looking at the column number, you're just going to ignore that 1 in front of the column number and use that remaining number as the number of valence electrons. In column 18, you'd have 8 valence electrons. In column 13, you'd have 3 valence electrons. So if we have 6, we're going to put 1, 2, 3, 4, 5, 6 dots around sulfur, and that's your completed diagram. Now let's take a look at one more example, and that's helium. This has the symbol He, not just an H is hydrogen, that E is important. On the periodic table, helium has the atomic number 2. Its mass is 4.003, but again, you don't care about that for Lewis diagrams. It's also in column 18. Now to begin with, for a Lewis diagram, we're going to put down the symbol. The symbol is He, so I'm going to put down a big He. And for Lewis diagrams, we want to put the number of valence electrons around it. Now, it's in column 18. You might think, oh, it's got 8 valence electrons. Well, the reason I wanted to do helium is because helium is the one and only exception to that rule of looking at the column numbers. All of the other elements up to 20, and that's all we're going to do for Lewis diagrams for now, all of the other elements will follow that column number rule. Helium doesn't, and the reason is pretty simple. Helium's atomic number is 2. That means it can only have 2 electrons. It obviously can't have 8 electrons in its valence shell if it only has 2 to begin with. So helium's the one exception, and helium is actually just going to take those 2 electrons and it's going to fill that first shell. Remember, the first shell can only hold 2 in the first place. So that valence shell, which is the outermost shell, is just its first shell, and that's got 2 electrons. So you can put those 2 dots anywhere you want around that He, and that's the completed structure for helium. He with 2 dots around it.